All right, welcome. So, if you're gearing up for the AWS Certified Developer exam, you already know IAM can be, well, a beast. But hey, don't worry. Today, we're going to break it all down. We're going to demystify exactly how AWS decides who gets to do what and really master this whole principle of least privilege thing. My goal is that by the end of this, you'll look at those tricky policy questions on the exam and just smile. You ready? Let's dive in.
Okay, let's kick things off with a problem that I'm sure every single developer out there knows way too well. I love this quote from the Netflix tech blog. We play a game of permission whack-a-mole. Because, wow, doesn't that just nail it? You know the drill, right? You get an error, you add a permission. You get another error, you add another permission. It's this super frustrating game, and it feels like it never ends.
So yeah, does that sound familiar? If you have ever battled one of those access denied errors, trust me, you are in exactly the right place. Being stuck in that loop, man, it just kills your momentum. The good news is, understanding the fundamental rules of how IAM works, I mean really understanding them, is the key. It's how you stop playing the game and start writing secure, effective code right from the get-go. Okay, so for our first section, let's really dig into this whole permission whack-a-mole problem. We've got to frame this thing properly to see why mastering IAM is just so critical when you're building on AWS. So the traditional way we do this, right, it's a grind. It's this manual, super time-consuming process of just trial and error. We write our code, we run it, bam, access denied. So we go into the console, we start tweaking policies. And this doesn't just slow us down. The real danger here, the thing we're all guilty of, is that we eventually just throw our hands up and grant something crazy broad, like S3 star, just to make the pain stop.
All right, so how do we finally win this whack-a-mole game? Simple. We have to understand the rules. So in Section 2, let's get into the nitty-gritty of how AWS decides access. We're going to break down the core logic that AWS uses for every single request. And for the exam, yeah, you've got to know this stuff cold.
So everything starts with two main flavors of policies. First, you've got your identity-based policies. These are the ones you stick on to a user, a group, or a role. They basically answer the question, what is this person or thing allowed to do in my account? Then you have resource-based policies. These get attached directly to the resource itself, like an S3 bucket, and they answer a different question, who is allowed to touch this specific thing?
And when it comes to deciding, AWS follows a super strict, predictable logic. It's always in this order. First, and most importantly, it scans all the policies looking for an explicit deny. It's basically looking for any reason to say, no way. If it doesn't find a deny, then, and only then, it looks for an explicit allow. It's looking for a reason to say, okay, you can come in. Now, what if it finds neither a deny nor an allow? The default is always, always no. Access is denied by default. So this brings us to the single most important rule in all of IAM. You have to burn this into your brain. An explicit deny always wins. It's the trump card. It doesn't matter if you have 100 allow policies screaming yes, if there is just one explicit deny for that action, anywhere in the evaluation logic, the answer is no. End of story. The deny always wins.
Okay, let's put that rule to the test with a classic exam-style question. So picture this. You've got a developer, and you've given them a pretty powerful policy with S3. They can basically do anything in S3. But at the tippy top of your AWS organization, you have a service control policy, an SCP that acts as a guardrail for the whole account. And that SCP has an explicit deny on the S3 delete bucket action. So what happens? And the answer is, the deny wins. Of course it does. This image shows it perfectly. The effective or final permissions for the developer are the intersection of what their own policy allows and what the SCP allows. Because the SCP has that hard deny on S3 delete bucket, it acts like a ceiling. It doesn't matter that the developer's policy says yes, the organizational rule says no, so the developer can't delete the bucket. This is a huge concept for the exam, so make sure you've got it.
Now let's talk about another type of guardrail, one you will absolutely see on the exam. It's called a permissions boundary. So if an SCP is like a big fence around your whole neighborhood, the whole AWS account or OU, a permissions boundary is like a fence you put around a single house. It sets the maximum permissions, a ceiling for just one specific user or role. It's a super important tool for when you need to delegate admin tasks, but you want to do it safely.
And here's the absolute key to understanding permissions boundaries, so listen up. A permissions boundary, on its own, grants zero permissions, nothing. All it does is define that ceiling, that maximum. For a user to actually be able to do something, the permission needs to be allowed in both their normal identity policy and in the permissions boundary. Again, think of it as an intersection. If it's not in the boundary, it's a no-go, no matter what their other policies might say.
Okay, so now we know the rules of the evaluation game. That's step one. But to actually win, both in the real world and on the exam, you need a strategy. And that winning strategy is all about the principle of least privilege.
And the idea is really simple. You grant a user, or a system, the absolute bare minimum set of permissions it needs to do its job, and nothing more. So you don't give a Lambda function DynamoDB star if all it needs to do is put item to a single table. You give it just put item for just that one table. That's it. Precision is the name of the game.
And here's what that looks like in practice. Let's take that Lambda function that needs to write to DynamoDB. The before policy here, yikes. That's the lazy way, right? Action, DynamoDB star, and resource, star. That's a huge security hole. But look at the after policy. This is beautiful. It's surgical. We've specified the exact action, DynamoDB, put item, and the exact resource ARN for that one table. This is what least privilege looks like, and this is exactly what AWS wants to see on the exam.
Okay, so least privilege is great, but you might be thinking, how do I do this for hundreds of users? I'm not going to write hundreds of policies. And you're right. That's where policy variables come in, and they are awesome. Think of them like placeholders. Look at the example here. By putting @AWS username right in the S3 resource RNN, we can write one policy that automatically gives every user access to their own personal home folder, and only their folder. It's least privilege, but it's scalable and elegant.
If you want to get even more granular, you've got the condition element. The easiest way to think about this is like an if statement inside your policy. It lets you add extra rules for when the policy should apply. So you could say, allow this action, but only if the request is coming from our corporate IP address, or only if the user has authenticated with MFA. It gives you this incredible fine-grained control. Okay, and we have to talk about this. A huge part of least privilege is knowing what not to do. And the number one thing is using your AWS account's root user for daily work. Just don't. It's the ultimate anti-pattern. Why? Because the root user has God mode. It has total, unrestricted access to everything, and it completely bypasses all the nice IAM rules we've been talking about. For your everyday development tasks, you should always be using IAM rules. Look, we all know that handcrafting these perfect, beautiful, least privilege policies can be tough. I mean, that's why we end up playing whack-a-mole in the first place. So that brings us to our final section. How can we get these permissions right, but do it a whole lot faster using modern tools? So let's think about two key scenarios. First, the inevitable happens. You get an access denied error. How do you figure out why without just randomly guessing? And second, how can you be proactive? How can you test your permissions before you ever run a line of code to see if it's going to work? Well, the good news is, AWS gives us some amazing tools so we can stop guessing. For being proactive, you've got IAM Access Analyzer. This is incredible. It can literally watch your CloudTrail logs, see what your application is actually doing, and then generate a perfect, tight, least privilege policy for you. It's like magic. And for when things go wrong, there are newer tools emerging that can actually analyze those cryptic access denied messages and suggest the exact fix you need. These are absolute game changers. So that leaves us with a pretty cool question to think about, right? With all these smart tools that can auto-generate policies and even fix our mistakes for us, is the era of permission whack-a-mole finally over? And I think what it means is that our role as developers is evolving. We're shifting away from being the people who painstakingly craft every single line of JSON. Instead, we're becoming the architects who guide and validate these incredibly powerful automated systems. The game hasn't just changed, it's like we've finally been given the cheat codes.